Hi, in this video I am going to explain about logic gates. A logic gate is a logic circuit with one input and one or more outputs. The output signal occurs only for certain input combinations. The input and output signals are digital in nature, that is either 0 or 1. All the possible input combinations and their corresponding output combinations are noted in a table called truth table. These logic gates or digital circuits constructed from diodes, transistors and resistors connected in such a way that the circuit output is the result of a basic logic operation performed on the inputs. A digital circuit is often constructed from small electronic circuits called logic gates. Each logic gate represents a function of Boolean logic. A truth table is describing how a logic circuit output depends on the logic levels present at the circuit's inputs. Boolean algebra differs in a major way from ordinary algebra in that Boolean constants and variables are allowed to have only two possible values, that is 0 or 1. The Boolean algebra was invented by George Boole. This algebra is used to solve logical problems. It's a set of rules, theorems and laws by which logical expressions can be expressed mathematically. It is convenient and systematic way of expressing and analyzing the operation of digital circuits and systems. In Boolean algebra, there are three basic logic operations: OR, AND and NOT. Some common representation of 0 and 1 is shown in the following table. The Boolean 0 and 1 do not represent actual numbers but instead represent the state of a voltage variable or what is called its logic level. The example for logic 0 and logic 1 is tabulated here. For example, logic 0 is false, off, low, no, open and switch. Open, switch. Logic 1 is true, on, high, yes and closed switch. A truth table is a listing of all the possible values each of the Boolean variables can take and of the corresponding value of the desired function. The basis of Boolean algebra lies in the operation of logical addition, that is the OR operation, and logical multiplication, that is AND operations. The another way to define the truth table is the rules that define a logic function are often represented in tabular form by means of a truth table. In digital systems, two different voltage levels are used to represent the logic levels 0 and 1. If the high voltage level, that is 5 volt, represents logic 1 and low voltage level, that is 0 volt, represents logic 0, then the system is called positive logic. But some systems use the low voltage level, that is 0 volt, for logic 1 and the high voltage level for logic 0. This is called negative logic. This is shown in the following figure. That positive logic means 0 to 1 instant. That is shown in the figure is 0 to 1 instant. This is called positive logic. And 1 to 0 triggering instance, that is 1 to 0. The waveform is going from 1 to 0 level. This instant is called negative logic. The basic logic gates are NOR gate, OR gate and AND. The Boolean addition and Boolean multiplication rules are used for logic gates. And this is the truth table representation for the two input logic gates. The two inputs considered as A, B and the output is Y. So the two inputs we can make four possible combination as 0, 0, 0, 1, 1, 0 and 1, 1. The 0 in terms of Boolean expression is A bar. 0 is represented as A bar, that is complemented from 0 is represented as complement inputs and 1 is represented as uncomplement inputs. So 0 0 the equivalent input Boolean expression combinations are A bar B bar. 0 1 means A bar B. 1 0 means A B bar. 1 1 means A B. This is the way to represent input signals. The OR gate has two or more inputs and only one output. It works according to the OR Boolean function. It follows the addition law. It gives output when any one of the input is at logic 1. The symbol, logic equation and truth table for OR gates are shown in the following figures. And this is the symbol for the OR gate. This is two input OR gates. The input 1 is A and the input 2 is B. So the output of the OR gate is Y is equal to A plus B. So based on that, here this is the truth table representation. The two inputs we made four possible combinations. So we are used to the Boolean addition rules. So here 0 plus 1, 0 plus 1, 1, 1 plus 0, 1 and 1 plus 1 is 1. Now let's use the Boolean addition rules here. So 0 plus 0 is equal to 0. That means Y is equal to A plus B. So we are adding A input and B input, that is the output Y. So now 0 plus 1 is equal to 1 and 1 plus 0 is equal to 1 and 1 plus 1 is equal to 1. So, but in the normal binary addition, 1 plus 1 is equal to 1, 0. That is sum and carry outputs. But in the Boolean addition rules, 1 plus 1 is equal to 1. The OR gate is represented as two switches connected in parallel combination. And this is the output lamp and this is input supply. So whenever any one of the input is connected, the lamp is on. If both the inputs are 0, that is open condition, the lamp is off. If any one of the input is connected, the lamp is on, or both the inputs are connected also, lamp is on. This is the symbol representation for the OR gate. This is an example for OR gate in an alarm system. Here the temperature sensor and pressure transducer is connected to comparators and the comparators output is connected to an OR gate. OR gate is output is connected to an alarm circuit. Now when any one of the input or both the inputs are high, then the OR gate will give an high output, so the alarm will be switched on. If both the inputs are in low conditions, the OR gate output is 0, so the alarm is in off conditions. Other three input conditions, the OR gate is enabled and the alarm is on. This is an example. The two inputs are represented in waveform method. Now this is input A and this is input B. Now based on the OR gate operations, we will see the output. Now this instant, the T0 to T1 instant, both the inputs are 0, the output is also 0. Now T1 to T2 instant, input A is 1 and B is 0. So the output 0 plus 1 is 1. Now T2 to T3 instant, both the inputs are high. So the output is also high. Now in the T3 to T4 instant, B input is high and A input is 0. So 0 plus 1, our output is 1. Now T4 to T5 instant, both the inputs are low, that is 0. So the output also 0. Now T5 to T6 instant, A input is 1 and B input is 0. So the output is 1. Now the T6 to T7 instant, both the inputs are high, that is 1. So the output also 1. This is the timing diagram representation for OR gate. The AND gate has two or more inputs and only one output. It works according to the AND Boolean function. It follows the multiplication law. It gives output only when all the inputs are at logic 1. This is the symbol for the AND gate. For two input AND gates, this is input A and this is input B and this is the output expressions. Y is equal to A dot B. The dot represents Boolean multiplication. And this is the truth table for an AND gates. For the two inputs, we made four possible combinations. So, we are applying the Boolean multiplication rules. From these rules, we can see when both the inputs are 1, 1, then only we are getting high output. Remaining all three conditions, we are getting 0 output. The same way, when 0, 0, y is equal to 0. 0, 1, y is equal to 0 and 1, 0, y is equal to 0 and 1, 1. The output y is equal to high. So this is the truth table representation. This is the waveform for input A and this is waveform for input B. Then let's see what is the output waveforms. So now 0 to T instant. This is 0 to T instant. Both the inputs are low, that is 0, 0. So the output is also low. Now T0 to T1 instant also both the inputs are low, 0, 0. So the output is also 0. Now T1 to T2 instant, both the input A is 1 and input B is 0. So 1 into 0, the output is 0. Now T2 to T3 instant and both the inputs are high. So the output is also high. Now T3 to T4 instant. The input A is 0 and input B is 1. So 1 into 0, the output is 0. Now T4 to T5 instant, both the inputs are low, so the output is low. Now T5 to T6 instant, input A is high and input B is low, so the output is low. Now T6 to T7, both the inputs are high, so the output is also high. This is the timing diagram representation for AND gate. The AND gate is equivalent to two switches are connected in series combinations. This is input A switch and this is input B and this is the lamp. Now when both the switches are high, that is connected, both the switches are in on condition, then only the power supply will go to the lamp and the lamp will be switched on. If any one of the inputs or both the inputs are low, the lamp is switched off. This is the simple example for an AND gate. The NOT gate has only one input and one output. It works according to the complementation law of Boolean algebra. Its output is the complement of the input. That is, the output is 1 when the input is 0 and the output is 0 when the input is 1. And this is the symbol for a NOT gate. It's a single input, single output gate. So the input is A, the output is A bar. That is, output is a complement of an input signal. So this is the truth table. It is a single input gate. So 2 power 1. So 2 power 1 input. So from this 2 power 1 we can make only two combinations, 0 and 1. So when the input is 0, output is 1 and whenever the input is 1, the output is 0. So the only two cases are present in the single input gate. In that waveform representation for NOT gate is the input 1 is high, the output is low. When the input is low, the output is high. This is the waveform representation for a NOT gate. The other name for a NOT gate is an inverter gate or complement gate. The NOT gate is represented as single throw double pole switch. So whenever the input is A, the output is A bar because it's connected in inverse combinations. The truth table 0 input, 1 output and 1 input, 0 output. The XOR gate, that means exclusive OR gate. The XOR gate has 2 or more inputs and only one output. It gives output only when the inputs are at different logic level. That is, when one input is 0 and the other input must be 1. This gate can be constructed using AND, OR and NOT gates. The symbol of this exclusive OR gate is this one. Here the input A and B and the output Y is equal to A exclusive B. The plus sign with circle is an exclusive symbol. Now let's see the truth table of XOR gate. From the truth table, when any one of the input is exclusively 1, we are getting high output. For this high output, our corresponding inputs are A bar B and AB bar. So based on that, our output expression Y is equal to A bar B plus AB bar. This is equal to A exclusive B. Now the logic diagram representation with the help of AND, OR and NOT gate is this one. So from this input A and input B, the output at this NOT gate is A bar and we are getting B output also. This place the output is A bar B and this place the output is AB bar. From this we are getting the output Y. Exclusive NOR gate, in short form XNOR gate. It is a combination of XOR gate and NOT gate. An XOR gate followed by a NOT gate is XNOR gate. It has 2 or more inputs and only one output. It gives output only when the inputs are at same logic levels, that is 0, 0 and 1, 1. This gate can be constructed using AND, OR and NOT gates. The symbol of this exclusive NOR gate is XOR gate with bubbles in the output. This is then XNOR gate representation. So the expression is A exclusive B the complement. And now let's see the truth table. In the truth table, whenever the two inputs are high, we are getting the output. So 0, 0 we are getting high output and 1, 1 we are getting high output. So from this we are taking the output combination for 0, 0 is A bar B bar and 1, 1 is AB. So from this the output expression Y is equal to AB plus A bar B bar. That is equal to A exclusive B the whole bar. This exclusive NOR gate is mainly used for comparator applications.